We have x cubed plus 3x squared minus 24x plus 1 on the interval from -1 to 4, and we want to try to find the absolute maximum and the absolute minimum point. So our two steps, we're going to take the derivative and set it equal to 0 to find any critical numbers. So bringing down this power, we have 3x squared. Bringing down 3 times 2 is going to give us 6x. Derivative of -24x is -24. Derivative of 1 is 0 because it's a constant. And we're going to take that derivative and set it equal to 0. We have an x squared and an x term, so we're going to have to factor this. So one thing I see I can pull out is a 3. So I have 3 times x squared would give me 3x squared. 3 times a positive 2x will give me positive 6x. And 3 times a -8 will give me -24. So you can pull out that greatest common factor of 3, and then I can continue trying to factor this. I want to think of something that multiplies to be a -8, so that must be a positive times a negative to multiply to be a -8, but adds up to be 2. So I need factors of 8 that differ by 2. So I'm going to use 4 and 2, and I'm going to make 4 the positive one so that it adds up to be a positive 2. So 4 times -2 is -8, and then 4 minus 2 is going to leave me with a positive 2x. All right, so now we've done that factoring, and we know 3 things can only multiply to be 0 as long as one of the factors is 0. So I want to try to set 3 equal to 0. I want to see if x plus 4 can equal 0, and I want to see if x minus 2 can equal 0. As long as one of these is 0, it will multiply to be 0. Well, 3 is always 3, so that's not going to be 0, but I could subtract 4 here. X equals -4, and then I could add 2 here, and I have x equals positive 2. So I have 2 critical numbers. I have -4 and positive 2. And now I'm going to do my second step. The second step would either be comparing endpoints to critical numbers that are on the interval, or if you don't have endpoints, that's when you would make a sign chart. Here we do have an interval. We're going to look from -1 to 4. So I'm going to plug in my lower endpoint first, f of -1 into the original function. And then I'm going to plug in f of 4, my upper endpoint, and any critical number that's on the interval of interest. So first of all, we have -4. Is that between -1 and 4? No. So I'm going to cross this. I'm going to say not on the interval. So I'm not going to erase it. It still is a critical number, but I just want to indicate, at least writing underneath, not on the interval. You can cross it out too. Just remember you don't have to test it, which is kind of nice. Hopefully neither of these critical numbers are on the interval, because then that's less y values I need to plug into my calculator to find. But my next critical number is 2. Is 2 on the interval between -1 and 4? Yes. So we do have to test 2. So we do have to test this one. We do not have to test -4. It's not on our interval. We don't care if it has a higher or lower y value. We can only look between -1 and 4 and find the absolute highest y value and the absolute lowest y value. So I'm going to plug into the original function to compare y values. If we plug in -1 to this big original function, we do -1 cubed plus 3 times -1 squared minus 24 times -1 plus 1. Plug into our long original function, we get 27. I do the same thing. I'd plug in 2 to the original function, and that gives me -27. And then if we plug in 4 to the original function, we're going to get 17. So now I'm going to look at these y values and figure out what's the absolute max point and what's the absolute min point. So we're just comparing y values between 27, -27, and 17. Which one's the absolute max? Well, the absolute max would be -1, 27, or if we're just asked for a value, the y value would be just 27. And the absolute min point would be at 2, -27. So again, all we've really done here is zoom in on part of the graph and say what's the highest y value and what's the lowest y value to give the absolute max and the absolute min.